It's the same page, second example there. It says this, we look at the vector v, like so. I call this similar because it's a different, this vector is slightly different from the one which is on page 18. The one which is on page 18, it's in fact, I think it's 1, 4, 3. No, it's 3, 1, 4, sorry. And you have this vector, and you have a plane. You have a plane with such vector equation like this. All of this in the equation. You have a vector, you have a plane, you have to test that your vector is parallel to the plane. That's a kind of example you're looking at on page 18, example number 2. Right. Good. First, before we can approach this question with the row echelon form, with the system of linear equations, or any other way, we have to first geometrically realize what they mean when they say parallel. How would we interpret this geometrical condition, vector being parallel to a plane, in terms of the algebraic relations? What do you think? How we will interpret that? Yes, if I give a name to this, it's a good practice when you name things, because it will make your writing simpler. If I call this A and if I call this B, then you're saying that the test for the being parallel will be V has to be a span of, so this is equivalent to V being a member of the span of A and B. As simple as this. And that's actually now brings us to the setting of the previous question. Now, when I test for this span, of course, this is like before. This is like the existence of two numbers, which are real numbers, such that V vector is a linear combination of A and B. That's what the span assume. Well, that's what the span. How we interpret this something being in a span. And this time, I will make my shortcut. This time, I will just produce this augmented matrix without going through the system of linear equations. Because effectively, the system is already here. The only difference is that now my coefficients here are vectors rather than numbers. So if I build my augmented matrix, here it is. I just fill in the matrix with the first column will be the components of the A vector. Here they are, negative 1, 3, 2. The second one is the components of the B vector, 3, 1, 4. And the right-hand side is my V vector. Here it is. It's a very simple question, and that's like the purpose of this exercise. Just, well, on one side I show you how to do that. Maybe some of you already know it. On the other side, you also see how you frame this and how you make the shortcuts in the other things to make your solution more understandable. Now, you bring this to the row echelon form. Again, I'm going to skip the details. You have your solution helper. I think it's, well, actually, because I said similar, in the solution helper, there's another vector there. But I think this time you probably will figure out how to do that. If you go to the row echelon without the solution helper. If you go to the row echelon form, the result of that, that's the row echelon form of this matrix. And all we have to do now, we have to interpret this row echelon form in terms of, do we have a solution or we don't have a solution? Yes, we do have a solution, because this time the right-hand side is not the leading column. As simple as this. And that's why this vector will be parallel to the plane in question. That's all there is to this example.